Hey guys, welcome to the notes for laws of exponents. We are in Unit 1, and our essential question is, how are the laws of exponents different from the basic rule of numbers? Okay, so we had a little bit of a sneak peek of what exponents kind of do when we talked about multiplying polynomials. So today we're going to talk about them a little bit more intensely. I will warn that this lesson can be difficult for some, so just be aware of that. So if you get a little bit frustrated, that's perfectly fine. Like, you just need to practice, and every problem is a little bit different. So I'm going to try to give you as many different ways to approach things, and you always have to come from a mindset of how can I make things more simple for myself. Okay, so we're going to go over some vocabulary first. So the first thing I'm going to go over is the base. Okay, and so there's two parts of a number that has a variable. There's the base, and then there's the exponent. So the base part is the number that is being multiplied. The number that is being multiplied. And then the exponent is the number of times the base is being multiplied. Okay, so the base is the number that is being multiplied, and the exponent is the number of times the base is being multiplied. So for example, we have x cubed here, right? X cubed here, I'm going to go ahead and identify the base. The base is the number that is being multiplied, so in this case, it would be the x. That's like the number, so that's the thing that you're multiplying over and over again. And then the exponent part tells you how many times you have it being multiplied. So the 3 is the exponent here. So you're taking x and you're multiplying it 3 different times. So remember, x cubed means x times x times x. So the base, which is x in this case, is the number that's being multiplied over and over again. And then the exponent, which is 3, tells you how many times it's being multiplied over and over again. So in this case, x is being multiplied over and over again 3 times. Okay, so what does 3 to the 4th mean? Well, 3 to the 4th means I have 3 times itself 4 times. So 3 times 3 times 3 times 3. 3 times itself 4 different times. What does x to the 5th mean? Very similar concept. You're taking x and multiplying it to itself 5 different times. So here's my question for you. Why do we write it this way? Why do we write x to the 5th instead of writing it out 5 times? Well, one reason is because it's a lot easier to just write x to the 5th rather than writing 5 x's out in a row. Because what if your exponent is like 12? Then you're going to have to write x 12 different times. And so we use this notation because it is shorter and we don't have to write it as much, right? We don't have to write 3 to 4 times because we can just say 3 to the 4th. So what does this mean? It means that there's 5 x's here. They're just all condensed and simplified, so you can't see all of them. But that x to the 5th represents that there are 5 x's being multiplied. So it doesn't look like 5 x's, it looks like just 1 x. But really, it's saying there's 5 x's here. Okay, so you want to be very mindful of that. Okay, so we're going to learn about 4 different laws today. We're going to learn about product law, the power law, power over product law, and then the quotient law. So we're learning about 4 different laws today. Okay, so we're going to go ahead and experiment with the product law first. So product law. We're going to practice first. So 6 squared times 6 cubed. Okay, well, what does 6 squared mean? Right, 6 squared means I have 6 times itself 2 different times, right? And then what does 6 cubed mean? 6 cubed means I have 6 times itself 3 different times. And then in the middle of these, I have that multiplication sign, right? So in total, how many 6's am I multiplying all together? I'm multiplying all together 5 6's. So this would be 6 to the 5th. Okay? So I would have 2 6's times 3 6's. So in total, I have 5 6's being multiplied together. Okay, so maybe you see a pattern already. And we kind of talked about it when we were multiplying exponents a little bit. All right, let's talk about x squared times x squared. Well, x squared means I have, and I'm talking about that first term here. So x squared means I have x times itself 2 times. And then the other x squared means I have x times itself 2 times as well. Okay, so I'm representing those 2 parts there. And then I have that black multiplication sign in between those 2 x squareds. Well, what does this simplify to? Well, if I have 2 x's being multiplied by 2 x's, then in total I have 4 x's being multiplied together. So I want you to look at the exponents and where they ended up. So We had 2 and 3, and then we ended with 5. Then we had 2 and 2, and we ended with 4. So what are we doing to the exponents? How do we get from the beginning exponents to the end exponent? We are adding the exponents, right? Because the 2 plus the 3 here made the 5, and then 2 plus 2 made the 4 over here. So we are adding the exponents essentially. Now, the only way for this to work is if you have the same base. Now remember, base is the bigger number. So the exponent is the smaller number, the base is the bigger number. So in this case, our bases are 6's. Over here, our bases are x's. You have to have the same base in order to combine them together, okay? You're allowed to have the same base, or you need the same base in order to combine them. If you do not have the same base, you cannot combine the exponent numbers, okay? Like for example, x squared times y squared, okay? If I multiply these together, I have x times x, and then I have y times y, but I can't combine these because they're not the same bases, because I have 2 separate x's and 2 separate y's, so the most I could have is x squared, y squared. I can't combine those. They're not the same base. Just like terms. You have to think about it like terms. You have to have like bases in order to combine them. Okay, so we're going to practice with some down here. So we have 5 to the 10th times 5 squared. Now what does 5 to the 10th mean? Well, 5 to the 10th means I have 10 5s, right? I have 10 of them being multiplied together, so I have 5 times 5 times 5 times 5, and so on. And then I have 5 squared, which is 5 times 5. So I have 10 5s being multiplied to 2 5s. So in total, how many 5s are being multiplied together here? I have 12 5s being multiplied together, so it'll be 5 to the 12th power. So really, I can write this out for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 5 to the 10th, and then you have 5 squared. And then you're multiplying those together. So then how many 5s are you multiplying all together? You're multiplying 12 of them together. So instead of writing all those 5s out, you're like, okay, let me just use the shortcut, which is the law, the product law, which tells me 10 plus 2, I have 12 of these. And the only reason why I can combine them is because they have the same base. I cannot combine them if they do not have the same base. Okay? All right. Remember, this is called the product law. I don't expect you to memorize the names, but I do expect you to know how to use the rule. All right, now number 2 here. Number 2 might be like, hey, I don't really know what to do here. Like, how do I get rid of these parentheses, right? Well, what do parentheses mean in math? It just means multiplication, right? So I want you to, before you get rid of the parentheses, just know, hey, they're being multiplied. How do I know that? Well, these parentheses are touching each other, so I know they're being multiplied. So really, I can just drop them. So negative 3x to the 4th times 2x cubed. Okay? Now I have 3x to the 4th times 2x cubed. Now here's an example of you need to only combine things that are like bases. Now just like terms, numbers are like bases. So like, for example, when we have like x squared minus 3 plus 2x plus 5, and I ask you, are there any like terms? And you're like, yeah, I can combine the negative 3 and the positive 5 together. Those are like terms. Regular numbers are like terms with each other. Well, just like with regular numbers, same thing happens when we're doing these types of problems. So I can actually combine the negative 3 and the 2 together. And I would multiply these. Why would I multiply negative 3 and 2? Well, because there's a multiplication sign there. So negative 3 times positive 2 is going to give me negative 6. Okay, so I'm multiplying here. When you're doing exponents, you're typically multiplying all of your variables together. Negative 3 times 2 is negative 6. And then I have x to the 4th and x cubed. Those are like bases, so I can combine those. Well, x to the 4th times x cubed is going to give me x to the 7th because I have 4 x's being multiplied to 3 x's, so in total I have 7 x's being multiplied together. Okay, so the like bases go together. The x's go together, regular numbers go together. Okay, and I'm going to go ahead and box my simplified expressions over here. Forgot to do that. All right, moving on to number 3. Number 3 might look a little bit intimidating. However, it's not too bad. Remember, the point of this is they're being multiplied together. They're all being multiplied together. So you combine anything that you can, which means you need to look for like bases. Okay, so I look for my like bases. Well, I see that I have a base of t here, and I see that I have another base of t over here. I have 2 bases of t, so I can combine those together, and that would make t to the 10th. because it can add the 8 and the 2 together. And again, I can prove to you why this is 10, right? Because I can expand this out, right? If I write all the t's out, which would take literally way too long, there's 8 t's. Here's 2 t's over here, right? So how many t's are being multiplied together? 10 in total. So instead of writing it all out, you can use that shortcut. And if you're having trouble using the shortcut, which is adding them, then expand it out, right? Write every single variable out. Some students do that. That's perfectly normal. Okay, so then I keep looking for like bases that I can combine. Well, I notice, hey, I have bases of m, and I have 2 of them, so I can go ahead and combine these. Remember, math is all about simplifying. You're trying to get things to be as simple as possible to be as small as possible. So I have m to the 12th and m to the 6th. So that's going to give me m to the 18th. I would add my exponents. And then I have k to the 6th and k to the 8th, which would give me k to the 14th. Now, how do I know I'm finished with my problem? Well, I can't combine any of my bases together, right? T, m, and k are not like bases, so I can't combine any of those together. So that's how I know I'm finished with this problem. Whoops. Okay, moving on to number 4. Now, number 4 is a little bit particular, and here is why. What's different about this one? Well, this one there's exponents, but there's also parentheses. Now, up here, we were able to get rid of the parentheses in number 2, right? We just dropped the parentheses because I know it means multiply. Here, I cannot drop the parentheses, and here's why. Those numbers are negatives, and when you have negative numbers, you have to put them in parentheses because your calculator doesn't know how to read it correctly if you don't put parentheses, okay? So for example, if I type in -4 cubed in my graphing calculator, -4 cubed would give me, I think, it would give me 64. Oh, -64, right? Or, that's actually a bad example. Let me do a different one. This one right here. -4 to the second. -4 to the second power. If I type this in my graphing calculator with parentheses, it will give me 16. But if I don't put the parentheses and I put it in my graphing calculator, it's going to give me -16. The parentheses are super important because what does -14 squared mean? Well, -14 squared means I have -4 times -4, right? -4 squared. Well, what's -4 times -4? Well, 2 negatives make a positive. 4 times 4 is 16. So -4 times -4 is 16. But if I type it in without parentheses, it's going to give me a number that's negative, which doesn't make any sense because -4 squared is supposed to be positive 16. Now, I don't know if the Desmos will do this. I know that on a graphing calculator, like on a TI calculator, it matters. So -4 squared should be 16. Now, let's try it without the parentheses. I don't know how it'll do it here. Here we go, right? So when you don't have the parentheses, it gives you -16, which doesn't make any sense because -4 times -4 is supposed to be positive 16. So if you don't put the parentheses there, your calculator will not be able to read it or understand what you're trying or wanting it to do. So you want to be super careful about that. But moving on, I wanted to point that out, but we're going to move on, right? So what is our base here? Our base here is -4, okay? Our base is -4. So I know that I have the same bases, right? I have -4 as one of the bases and -4 as the other base. So I can actually combine these -4's together, okay? I can combine the -4's together. Whoops. Oh gosh, it's bothering me. I can combine the -4's together. So how many -4's are being multiplied together here? There's 5 of them being multiplied together because I have 3 being multiplied to 2 bases of -4. So in total, I have 5. Okay, right? Because this is -4 times -4 times -4, and then this is -4 times -4, right? There's 3 of them here, there's 2 of them here. So in total, how many -4's are being multiplied? 5. All right. So moving on, let me go ahead and box that answer. Ooh, that's an ugly box. That's also an ugly box, but we'll live with it, right? Actually, I can't. There's part of me in my brain that's like, nope, can't, doesn't work, can't do that. Too ugly. Good enough. All right, we're going to move on to the power law. So this is the second law that we learn. Okay, so the power law is one with parentheses. And so you're going to be super, super careful about this, okay? Because this is different from the previous one, which is the product law. As you notice, as we were going through each problem, if they had the same base, I would add the exponents, right? So I would add the exponents. Power law is not the same thing. You're not adding the exponents. So what do you do here? Well, let's let's test this out. The whole part of this is we're going to experiment to figure out what this law is. Oh, and I forgot. So sorry. All right, I didn't even give you the official law for product law. All right, the product law, I'll write it in, what color should I use? Pink. Okay, what is the product law, right? So the product law, if I were to write this out in like formula form, this would be a to the m times a, actually let's use a, let's use x to the m times x to the n, right? So the product law says, if I have the same base, in this case I have the same base, x and x, if I have the same base and they're being multiplied, what can I do to those exponents? I add them. So if I have x to the m times x to the n, then I would have x to the m plus n, whatever that sum is, whatever they would be added together. So I'm basically writing this out in formula form. So that would be the formula for product law. Okay? If I have one base being multiplied to another base, I can just add their exponents. So whatever m and n are, I would add those. Okay, so let's move on to the power law over here. Okay, so x to the fifth to the third power. Okay, well, we just learned something about exponents, right? It's telling me that I have x to the fifth 3 times, right? So let's write x to the fifth out 3 times. So x to the fifth cubed would be x to the fifth times x to the fifth times x to the fifth, okay? So it's saying that I have x to the fifth 3 times being multiplied together. Well, what do you notice about this? I have the same base, right? I have the same base. So what does that mean I can do? I can add my exponents, correct? So let's add these together. I have 5, 5, and 5. They're all the same base. They are x, 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 so I'm allowed to add them together. Okay, so in total, how many x's are being multiplied together? There's 15 of them being multiplied together, right? I have 5x's times 5x's times 5x's. So in total, I have 15 x's being multiplied together. So I want you to think about this. What happened to our beginning exponents and how did we get to the end? What do you think we do there? Instead of writing it all out like this every single time, what's the shortcut to go from here to here? I would multiply the exponents. So here we are multiplying. You multiply the exponents. Think about it like you're kind of like distributing, okay? You're distributing. Remember, distributing is the opposite operation of multiplication. And I'm not going to forget, I'm going to give you the formula for power law this time. So the formula says if I have x to the m and it's raised, right? It's raised and there's parentheses to the power of n. What do I do with those 2 exponents to get the new exponent? I would multiply them. So this would be m times n. Okay, so 5 times 3 would give me 15. So to go from the shortcut, instead of writing it all of this stuff out every single time, I use the shortcut. If there are parentheses, I would multiply. Now, how do you tell the difference between the previous law and this law? Notice how there are parentheses. Think about every time in math when we have parentheses, like this case, for example. How do I get rid of the parentheses? I distribute. And when you distribute, what operation is that? Multiplication. So when you see parentheses, you need to automatically switch to multiplication because you're like, okay, multiply. You need to multiply. All right, so starting with number 1. We have 4 squared to the 6th power. Okay, so this is where I see, okay, I see parentheses, so I'm going to multiply. Okay, I'm going to multiply 6 times 2, so I have 4 to the 12th. I am multiplying the parentheses to each other, okay? I would multiply. Now, how do I know this is true? Well, this is saying that I have 4 squared 6 times. So I have 4 squared times 4 squared times 4 squared. And you don't have to write this down, but I'm proving to you why this is 12. So then how many 4s am I being multiplied together? Well, I have 2, 4, 6, 8, 10, 12 of them together. But this is a lot to do every single time. Now, if you want to do that every single time, you can. But the shortcut is you multiply those exponents together. Okay. And you're finished because there's nothing else you can do with this problem, right? All right, moving on. Number 2, okay? Number 2, okay, this one's a little bit weird because there's a fraction, but it doesn't matter. You treat it exactly the same. You see that you have 2 exponents and you got to get rid of those parentheses. You want to get rid of them. Well, in order to get rid of them, okay, what would I do? Well, I would want to multiply them. Why would I multiply and not add? Because parentheses. Parentheses mean multiplication to me. So I'm going to distribute and multiply. So I have y, and then 8 times 1/2. Okay, 8 times 1/2, not 8 plus 1/2. 8 times 1/2 is going to give me 4. And again, you can always pop that into Desmos. 8 times 1/2, and you get 4. So y to the 4th is my simplified expression over here. Okay, moving on to number 3. Number 3 looks like a mess because there's 2 sets of parentheses. Remember, why is there an extra set of parentheses here? Because our base is negative. We want to keep the parentheses around negative numbers because that messes up things, right? Like I showed you over here with the -4s. If I don't put the parentheses around the -4 in the calculator, it gives me the wrong answer. So that's why there's an extra set of parentheses in this problem. But you want to treat it exactly the same as you would, and you're still going to multiply the exponents together to simplify this. Why am I multiplying and not adding? Because there are parentheses, so you're distributing. Distributing is multiplication, so do not add. Okay, so in total, in the end, I have -1 to the 12th power, because 4 times 3 is 12. And yes, I would keep those parentheses. I cannot get rid of them because that number is negative, so I want to make sure that I keep it that way. Also, you can also simplify this as well, because this is just a number, right? So if I type in y to the 4th in Desmos, it's just going to give me y to the 4th. Like, it doesn't have an answer to give me because it's not a number. It doesn't know what y is. But -1 to the 12th, these are all numbers. I can actually punch this into Desmos, and I'll actually show you something. So -1 to the power of 12. That gives me 1. So how did I get that, right? So what does -1 to the 12th power mean? It means I'm taking -1 and multiplying it to itself 12 times. And when I multiply it to itself 12 times, I end up with +1. So really, you could simplify this even further and just say, this answer equals 1. And you can actually do the same thing with 4 to the 12th, but 4 to the 12th is a really big number. Again, why am I able to plug this in a calculator and not this in a calculator? Because number 1 has a real number, okay? It has a number, whereas number 2 uses y, and the calculator doesn't know what y is, so we can't put anything in the calculator for that. So I can actually plug in 4 to the 12th in the calculator, but it's going to give me something nasty, like a huge number. You see that? You could write that if you wanted to, but I'm not going to. All right, now number 4. All right, now number 4 looks a little bit strange too, because you're like, what is this? I don't understand. It seems like it's missing something, right? So you want to get rid of the parentheses. So typically you would distribute to whatever exponent is there. But remember, when the exponent's not there, what number is really there? There's really a 1 there. So what's 1 times 4? Just 4. So this is m to the 4th. So you want to make sure if the exponent is not there, there is a 1 there. So you want to be super careful about that. Okay, so we've gone through 2 laws. We've gone through the product law, okay? The product law says if I have 2 bases, now there's no parentheses in these problems. If I have 2 bases, then I can add the exponents together, right? So like here, I have x squared times x squared. I can add those 2's together and get x to the 4th. If I have 6 squared times 6 cubed, I can add those together and get 6 to the 5th. The power law says if I have 2 exponents touching each other through parentheses, right? So right here I have 5 parentheses to 3. Then I want to get rid of those parentheses by distributing. So I would multiply those exponents. So I do 5 times 3 and I get x to the 15th. Okay? And in number 3, you don't want to get rid of those parentheses because that is a negative number. And when you have a negative number, you want to be super careful about that because you want to leave those parentheses there so that you punch it in the calculator correctly. All right, so we're going to move on to our 3rd law, which is power of a product law. Okay, now this is a little bit of a combination of the last law, but a little bit extended. So it's using this law that we just learned, the power law, and then extending it a little bit further. So it's like, okay, what happens now if there's 2 variables in those parentheses, okay? So let's expand this to see how we can get the law. Okay, xy to the 3rd power. So x times y to the 3rd power. Now remember, x and y are being multiplied. We just don't write that multiplication sign. So it's saying that it has x times y 3 times. So let's expand that out. We have xy times xy times xy. Okay? So I have x times y times x times y times x times y. Well, the rule says if I have like bases, I can combine those, right? So I have like bases with x. I have an x here, I have an x here, and I have an x here. So in total, how many x's are being multiplied together? 3 of them. So I have x cubed. I'll go ahead and write an equal sign here. Okay? And then I can also combine the y's together because those are like bases. Remember, bases are the bigger numbers, right? So like The exponents are the little tiny numbers, bases are the bigger. So I have a y here, I have a y here, and I have a y here. So in total, I have 3 y's being multiplied together, or in other words, y cubed. So goal is, how do I get from one to the other, right? So I started with a 3 on the outside of the parentheses, and then I end up with a 3 on each variable over here. So what does it look like it just happened? It looks like I distributed, right? It looks like I distributed that 3 in, correct? Now, distributing means you're multiplying, right? So what's the exponent on the x and the y here if they don't write it? They're both a 1. So if I do 3 times 1, I have y to the third because 3 times 1 is 3. And then I can do the same thing to the x. What's 1 times 3? Also 3. So I just have x cubed, y cubed, which is exactly what I end up with. So instead of doing, whoa, I just realized this became like a solid color. Give me 1 second. Okay, moving on. Now, instead of doing this every single time and expanding it out, I can just remember the shortcut. The shortcut says, if I have parentheses, just distribute that exponent in to all of the other exponents. So that's what we're going to do here. Okay, so I'm going to go ahead and give you the formula for power of a product law. So this says if I have a, b, I don't know why I keep using a, I'm going to use x, y. I think typically we use a, b. I think on your formula chart on the STAR test, it uses A, B. So I might go back and change these to A, B, A's and B's. Right, so this would be A to the M to the N power would be A to the M times N. So I'm just changing out the X's with the A. And then the previous one would be A to the M, times A to the N equals A to the M plus N. I'm going to make sure I give you what the STAR test gives you. So STAR test, I think, uses A. The formula chart has an A on it. So it's the same thing. I'm just replacing the X's with A's because that's what they use. So we're going to use A's. So actually in this problem, I'm going to start using A's and not the B's. Oops. Okay, so this says I have A, B to the M power. How do I get rid of those parentheses? Well, I would distribute that M exponent to all of the bases inside the parentheses. So I had A to the M and then B to the M. So it's basically what we just had with the X and Y, but just in formula form. So this is the formula form, right? If I have parentheses with 2 variables inside, I can distribute that exponent in. So in retrospect, what are we doing? We are distributing, right? Remember, distributing is multiplication. We are distributing the outside exponent, okay? So the outside exponent, just like when we distribute with numbers, right, like this, we distribute the outside term into the parentheses. Well, here we're taking the outside exponent, okay, exponent. Let me highlight exponent real quick. We're taking the outside exponent and we're distributing it to all the other exponents inside the parentheses. Now again, we did that with the x's. The x and the y didn't have an exponent, but they're a 1. So we're distributing it to those exponents. We're not distributing it to x, right? So for example, this does not make 3x, okay? It does not make that. You're distributing it to the exponent that x has, which in this case is 1, so 3 times 1 is 3. Okay, so you're distributing that outside exponent inside to the other exponents. Okay, so we're going to practice this, and I have 6 problems for us to practice on this one because it can be a little bit of a trick. So number 1, okay? Now, again, super careful with this one because this is the ones we mess up all the time. Okay, so how many bases do I have inside my parentheses? Bases. Remember, bases are the big numbers or variables, the big ones, not the baby ones. There's 2 bases here, okay? 2 is a base and x is a base, okay? So when I distribute that 3 is going to be distributed to 2 bases, okay? It's going to get distributed to the 2 and to the x. Now, what is the exponent on the 2? What is the exponent? It's a 1, right? They didn't write it there, but it's a 1. So you want to be really careful about that because there really is a 1 there. You just don't see it. So I'm going to distribute and get rid of the parentheses, get rid of that 3 on the outside, and we're going to use the law, which says I'm going to distribute and multiply to get rid of the parentheses. So when I distribute here, it's going to be 2 to the 3rd power, 2 to the 3rd, okay? The most common mistake is people do 2 times 3. They do 2 times 3. and then they get 6. 2 to the third is not 2 times 3. 2 to the third is not 2 times 3. Yeah, it's not 6. Okay, now how did I get 2 to the third? Remember, you're multiplying it to the exponent. The 1 is the exponent. The 2 is not an exponent. You're not going to take 3 times 2. That makes no sense, right? People will do that. People will be like, 2 times 3, that is 6. I'm like, no, that is not 6. Okay, you're multiplying the exponent, so 2 to the third power. And then you're going to do the same thing with the other base, the x. And you're going to distribute and multiply these exponents together, so you get x to the 12th. Okay? Now we're going to go ahead and simplify this. What is 2 to the third? 2 to the third is 8, not 6. Because 2 to the third means you have 2 times 2 times 2. And you can also type in 2 to the third in your calculator, and it'll give you 8 as well. So I don't have any like bases, so I'm finished. That's all I can do with number 1. Okay, moving on to number 2. 5m to the second power. Okay, now how many bases do I have inside the parentheses? I have 2 bases. I have a 5 and I have an m. I have 2 bases. And you want to go ahead and identify all the exponents of your bases so you don't mess this up. The exponent on the 5 is a 1, and the exponent on the m is a 1. Now I know this because if they don't write it, there's really a 1 there. So you want to be super careful about that. Okay? So I'm going to go ahead and distribute the 2 to the 5. So I'm going to distribute the exponent of 2. This is not 5 times 2. Please make sure you're listening. This is not 5 times 2. That is completely different. Okay? So what do you do here? You're multiplying the exponents together. So you're not even doing anything with the 5, but you're multiplying the 1 times the 2, which is 2. And then you're going to do the same thing with the m and their exponents. 1 times 2 is 2. Okay? And then you want to simplify this even further. Okay? You don't want to leave it as 5 squared because can you punch 5 squared in a calculator? Yes, you can. What is 5 squared in a calculator? 5 squared is 5 times 5, which is 25. And then you can't do anything with the m, so that's going to stay m squared. You don't have any like bases that you can combine, so this is your final answer. All right, moving on to number 3. Number 3, how many bases do you have inside your parentheses? How many bases? We have 3 bases. We have 3, x, and y. There's 3 separate bases here, so I'm going to be super careful. Make sure you distribute to all of those bases. So you're going to take the exponent that's on the outside of the parentheses and distribute it all in. So you're going to make sure you've identified all the exponents to make sure you don't miss any. Well, there's no exponent on the 3, but I know that there's really a 1 there. We just don't write it there because it would look really silly, right? We just don't write it. But I'm going to go ahead and distribute the 4 in there. So remember, we're doing 1 times 4, so this would be 3 to the 4th power. 1 times 4 is 4. Okay, and you're going to multiply those exponents. You have x to the 12th. And then you have y to the 8th. Now again, what did I say was the most common mistake? They always mess up at the front. They always accidentally do this. So instead of doing 3 to the 4th, they will write 12 for me here because they do 3 times 4. 3 times 4 and 3 to the 4th are 2 completely different things. So it's super important we don't accidentally mess that up. Now, before you box your answer, you always check, can I type anything in my calculator to make this more simple? I can type in 3 to the 4th. So what is 3 to the 4th? I think it's 81. So you do 3, and then to know what to do the exponent button in Desmos, it's actually this button right here. It's a to the b. So you type a to the b, and it'll bring it up the exponent, and then you type a 4. And then you get 81. So 3 to the 4th is 81. And then I have x to the 12th and y to the 8th, because those aren't like bases, so I can't do anything with those. And so I'm finished with my problem, and this is my final expression there. Okay, moving on to number 4. Now number 4 is tricky because if you notice, that -4 in the front is a negative. It is a negative, which means we're going to need a set of parentheses when we're doing this. Because again, if I type this in the calculator without parentheses, I don't get the right answer, okay? So we're going to go ahead and start, and we're going to identify all of our exponents so that we don't mess this up. What's the exponent on the -4? It's a 1. What's the exponent on the x? It's a 1. And then the exponent on the y is a 2. So I always want to make sure I identify all of those so I don't miss them. So when I distribute this 2 in, I'm multiplying it to the exponent. So this would be -4, and then 1 times 2 would be 2. However, this is a negative number, which means I need to have parentheses. Because remember, if I type it in without the parentheses in the calculator, it's going to give me the wrong answer. So please remember the parentheses. Parentheses are super important because it's negative. Okay? And then you're going to move on to the x. So I'm going to distribute the 2 to the exponent that's on the x. So 1 times 2 is 2. Okay? And then I have the same thing, or not same thing, but I have I'm not going to use green because I use green up there. I'm going to use blue. Okay, you're going to do 2 times 2 for the y exponent, so that would be 4. Okay, so this is what I have so far. Now, I would be finished, however, you always want to check. And because that pink, the -4 to the second power, can be typed in the calculator, I want to make sure I do that. And again, those parentheses are super important. You have to type them in. Parentheses, -4, close parentheses. And again, this is the exponent button, the a to the b power here. So I do that button and then 2. I get positive 16. Okay? Again, what happens if I don't have the parentheses? I get negative 16. So remember, -4 times -4 is positive 16. So you want to make sure you get the right answer when you do this. So this would be positive 16, x to the second, y to the fourth. So that would be my final expression for number 4. All right, moving on to number 5. Number 5 looks a little bit scary because you're like, there's a fraction here. Like, what do I do? Nothing different. You do the same thing that you would always typically do. You're still going to try to get rid of these parentheses by distributing the outside exponent in. Now I will say, okay, you still need to identify. Now 1/4 is ugly, right? It's a fraction, I know. It doesn't look cute. But what is the exponent on the 1/4? It is a 1, right? So you want to keep that exponent there. You want to be like, hey, there's an exponent still there, so I want to make sure I keep that there. So the exponent on the h is a 5, and the exponent on the k is a 3. So always identify all your exponents so that you don't mess this up. Okay, so then you're going to go ahead and distribute, and I always like to do the first base first. So we have 3 bases here. The 1/4 is a base, h is a base, and k is a base. So this I have 1/4, and then 1 times 3 is 3, okay? Now this is a fraction, so I would recommend that you put parentheses around this one as well, just so that the calculator knows how to read it. Sometimes it can mess up, sometimes. So just in case, I would put a parentheses around it. Okay, and then for the h base, right, you're going to multiply those exponents together, so you have h to the 15th. 5 times 3 is 15. And then the k exponent would be 3 times 3, would be k to the 9th. So you're multiplying all those exponents together, okay? I'm double checking to make sure all of my answers are the same as my key. Yes, we're good. Okay, but I'm almost finished. I'm not quite finished because 1/4 to the 3rd, while it is a fraction, I can type that in a calculator. So I'm going to go ahead and do that, and I'm going to show you how. And I'm going to use parentheses. So I'm going to use parentheses. And then 1/4 would be 1 divided by 4. So 1 divided by 4. And then I want to tap out. So you want to make sure that you go outside of the denominator and then put in closing parentheses. So I have 1/4. Then remember, this is the exponent button. So you're going to do exponent 3. And then you get this ugly decimal. Now to remember, to turn something to a fraction, because I hate decimals like that, there's this little blue area over here. I'm going over it with my cursor, right? There's a little fraction button. If you click on it, it's going to give me 1/64. You want to keep it as a fraction. So this simplifies to 1/64, and then, oh, not y, h to the 15th, and then k to the 9th. So now this is in simplest form. So you want to go ahead and type in your beginning number if you can in the calculator. All right, last one for this law. And I'm going to go ahead and move these up. I'll shrink it a little bit. Okay, number 6. Now this one again looks scary. There's a fraction involved. The process is exactly the same. You're still going to distribute that exponent into all the other exponents. Remember, distributing is multiplication, so be careful because people like to mess this one up. All right, now what is the exponent on 36? The exponent on 36 is a 1. The exponent on the w is a 6, and the exponent on the v is a 10. So here we have 3 bases, and they all have an exponent, okay? So we're going to go ahead and distribute the 1/2 in. Now you're going to do 1 times 1/2, which is just going to be 1/2. So I have 36 to the 1/2 power, okay? I know that looks weird because it's a fraction, but it's okay. You're going to treat it exactly the same. You still multiply. 1 times 1/2 is 1/2. Okay, now you're going to multiply these exponents. So you have w. 6 times 1/2 is 3. Make sure you know how to use that calculator. Make sure you know how to type in those fractions. 6 times 1/2 is 3. Then I have 10 times 1/2. So v to the 10 times 1/2. 10 times 1/2 is 5. Now I would be done. However, I can type in 36 to the half in a calculator. Okay, so again, you're going to type it in. You type in 36. Use the exponent button. And then you're going to do 1/2. So that's going to be 1 divided by 2. 1 divided by 2. And I get 6. So it's actually a pretty number. Not even that ugly, right? So 36 to the 1/2 simplifies to 6. And then I can't simplify the w or the v because obviously they're variables and we don't know what they are. So we have to leave those as is. But this would be my simplified expression here. Oops. Okay. All right, we have the last page left, which is the quotient law. So we have 6 examples there. So we're going to go through these. Now the quotient law, all right, and I will go over the law in a second. We're going to go ahead and, do our little testing, right? We're going to test this. So what does 6 to the 5th mean? Well, 6 to the 5th means I have 6 times itself 5 times, right? Divided by 6 squared. Well, what's 6 squared means? It means I have 6 times itself 2 times. So you can cancel some of these out, right? We can cancel some of these. So I can cancel those 6s, and I can cancel these 6s. Those cancel. So then let me ask you, how many 6s do I have left? I have 3 in the top, right? 3 in the numerator. I have 3 6s left. I don't have anything in the denominator left. Does that mean I have 0? No. How did these cancel? How did the 6s cancel? Because 6 divided by 6, right? This is technically a fraction. 6 divided by 6. What is that? It's 1, right? If I type in 6 divided by 6, 6 divided by 6, I get 1. So what's really there in the bottom of my fraction? A 1, right? So every number that I write, like for example, 3, that's 3 over 1. But we don't write 3 over 1 because that's a lot of work. But they mean the same exact thing. We just never write the 1 there. So there's really a 1 in the denominator, not 0. So you have to be really careful about that. But really, this is just going to be 6 times 6 times 6, okay? Well, what's 6 times 6 times 6? How can I shorten that and condense it and make it smaller? Well, 6 times 6 times 6 would be 6 cubed. Okay? So that's going to be 6 cubed. So then question. Look at what you started with, and then look at what you ended with. So look at all the work that we had to do in the middle. Look at all of this. This is a lot of work each time. So that's why these shortcuts, these laws are really important. So you have to use them to the best of your ability. Okay, and I'm going to change this color because, that's okay. I'm not going to change the color. Okay, so how did I go from 5 and 2 and get to 3? What happened to those exponents? They subtracted. 5 minus 2 becomes 3. So let's see if it's the same rule for those x's here. So let's try this. X to the 4th means I have x times itself 4 times in the numerator. And then I just have a single x in the denominator. So can I cancel any of these x's out? Sure. And it doesn't matter which set you cancel out, so I'm going to just cancel out the last one. Okay, it doesn't really matter which ones you cancel out. Equals, how many x's do you have remaining in the numerator? You have 3 x's remaining in the numerator. Nothing remaining in the denominator, but technically there's a 1 there. We just don't write it. So really, without writing the 1, because it's the same thing, x times x times x is the same. So how do I shorten x times x times x? Well, this would be x cubed. So then you can look. How did I go from the beginning exponents? Now, what is the exponent on this x down here? It's a 1. So we have 4 and a 1, and then we end with 3. So how did we do that? We subtracted. 4 minus 1 is 3. 5 minus 2 is 3. That's how we ended up with those 3's in the end. So what is the quotient law? I'll go ahead and write it for you. If I have a to the m divided by a to the n. So this is saying if I have the same base, right? Because notice how both of these bases are the same, a and a. If I have the same base, to simplify this, I would subtract. So when you're multiplying, you add, but when you are dividing, you subtract. So again, dividing, when I think about a subtract, think about that division bar like a big subtraction sign. So think about a minus sign, okay? So you're going to subtract these exponents from each other. So what are we doing? We are subtracting the exponents. you're subtracting those exponents. But in order for this to happen, they must have the same base, right? So notice the 6's can go together because they're the same base. X's can go together because they have the same base. But if I have a W and a Z, can't do anything. They're not the same base. Can't combine them. Doesn't work. Just like with like terms, like bases, those exist. You want to be super careful about those. Oh gosh, I'm getting so many emails. All right. So we're going to go ahead and go through these problems real quick, and then we'll be done with the notes. So now there's a little bit of a trick to this because people get confused because you're like, you just told me to subtract and now you're telling me to divide. Okay. Essentially, this is a division bar. This is division, right? You want to make sure that you're thinking about it like it is division because it is division, okay? So you can only combine things that are like bases. So for example, 6 and 3 here are like bases. What is 6 divided by 3? Think about that. What is 6 divided by 3? Okay, 6 divided by 3 is 2 over 1, right? It's 2 over 1. Do you agree? 6 divided by 3? If I get 6 divided by 3, I get 2. How can I write 2 as a fraction? 2 over 1. Now I'm going to show you in a second. Do I really need to write a fraction every time? No, but I'll show you exactly why. Now, you have other like bases. You have x to the 10th and x to the 5th. So then you play the game of where are there more x's? Where are there more x's in this problem? Are there more x's in the numerator or the denominator? More in the top or the bottom? There's more in the numerator. Okay, there's 10 in the numerator. How many more? So you subtract. What's 10 minus 5? 5. Okay, now is it necessary for me to write that this is all divided by 1? No, I don't have to write that. So I could just write 10x to the 5th and I'll be finished. Okay, now I write that 1 there just in case there happens to be something in the bottom of my fraction. But because there isn't anything in the bottom, it's just a 1 and I don't really need it, I can get rid of it. All right, moving on to number 2. Negative 9v to the 5th divided by 6v to the 8th. Again, you can only combine things or simplify things that are of like bases. So negative 9 and 6 are like bases. Now, if I put this in a calculator and divide it, okay, negative 9 divided by 6, I get a decimal. You want to leave it as a fraction. So you want to make sure you hit this little blue fraction bar over here. You get negative 3 over 2. So I'm going to go ahead and write negative 3 over 2. Negative 3 over 2. I'm going to make my fraction bar big so that I have room to, write whatever I need to write. And then you're going to look at your v's. You have v to the 5th and v to the 8th. Those are like bases, so I can simplify those, okay? Where are there more v's? There's more v's in the bottom, okay? Where are there more? How many more? There's 3 more. 8 minus 5 is 3. So you look for how many more are there. If there's more in the bottom, put it in the bottom. If there's more in the top, put it in the top. Okay, did you simplify everything? Yeah. Is there anything left for me to do? Can I simplify anything left at the end? No. How do you know you're done? When you can't combine anything left. So what is our final answer here? Negative 3 over 2v cubed. Now I'm going to put the negative in the front, but really it doesn't matter. You just need it somewhere, so it doesn't really matter where you put the negative sign. I like to put mine in the front. I don't like to put it in the top or the bottom, so it means the same thing though. Okay, moving on to number 3. Okay, now this one's a little bit different because you're like, there's a fraction and there's a parentheses. Like, what's going on here? Okay, so first goal is look inside the parentheses. Can you simplify anything on the inside here? So let's look. Well, I have a 3, I have an x, a y, and a z. None of these are like bases. So I can't simplify any of these. So the main thing is get rid of the parentheses. How do I get rid of the parentheses? I know I have to distribute this 3, but you want to make sure you distribute it to every base that you have. So I want you to look inside the parentheses. How many bases do you have here? You have 4 bases. 3, x, y, and z. Those are 4 bases. So you're going to have to distribute the 3 to 4 different bases. Go ahead and identify the exponent so that you don't mess this up, right? What's the exponent on the 3? The exponent on the 3 is a 1. The exponent on the z is also a 1. Exponent on the x is a 2. The exponent on the y is a 5. So you're going to make sure you identify all of those. And so we're going to go ahead and distribute. So I'm going to draw my fraction bar. Okay. Distribute this in. So I have 3. And then I'm going to do 1 times 3. You only multiply the exponents. So 1 times 3 would be 3. All right. And then we have 2 times 3, which is 6. Remember, distributing is multiplication, so make sure you are multiplying. Okay. And then we have y to the 15th because 5 times 3 is 15. And then don't forget about that z down there. You multiply to every base. So this would be z to the third power, 1 times 3. Remember, when you're distributing, you are multiplying. Okay, now you're almost finished. However, it is not finished because you can simplify 3 to the third, okay? So I can simplify this. What is 3 cubed? Well, 3 cubed is 27, okay? Now I can't do anything with the x, y, z because I don't know what those numbers are, but I can type in 3 cubed in a calculator, 3 cubed, and I get 27. So that's why I want to simplify that to keep it in simplest form. And then that is my final answer. I can't do anything else with it. That is the ugliest rectangle I've ever made. Okay, there we go. Number 4, I almost said -4. Number 4, same thing here. I want to look inside the parentheses and see if I can simplify anything. And when I look inside, there are no like bases. Okay, so I know I got to get rid of the parentheses, so I'm going to distribute that to exponent that's on the outside. But I want to go ahead and identify all of the exponents on the inside. So the -2 is a base. The exponent on the -2 is a 1. The exponent on the m is a 7, and the exponent on the n is a 3. Okay, and then I don't want to forget about the exponent on the r, which is also a 1. Remember, if it's not written, it is a 1. Okay. Now I'm going to go ahead and distribute these in, and you want to make sure you get to every base. So this would be -2, and then I want to do 1 times 2 because you multiply the exponents, and that would be 2. Notice, you have a negative number. So what do we need? We need parentheses. Use parentheses when you see negatives. That's super important. Okay? And then you're going to multiply the exponents on the m and get 14. Multiply the exponents on the n and get 6 because 3 times 2 is 6. Draw my fraction bar, and then I have, remember, don't forget about the r down there because you do have a denominator. This would be r to the 2nd. Now, this is almost simplified. However, that red number is a normal number, so I can type that in a calculator. And when I type in -2 squared, remember, you want to use parentheses. So -2 squared, it'd be +4. What happens if I don't have parentheses? I don't get +4, I get -4. So be careful, use those parentheses, you get +4. So it'll be 4, and then I'm going to use a shortcut so I don't have to copy all this and paste it. So paste. Look at me using shortcuts, the easy way out, right? Okay, sorry. So I'd have the exact same thing, but I want to simplify the red part there. All right, moving on to number 5. So we're almost done. Now there aren't any parentheses here, so there's nothing for me to distribute in, but I do have like bases, so I want to go ahead and simplify those. Now, I have like bases with the -4. Remember, regular numbers are like bases with each other. Now, remember, this giant bar means divide, so I want to do -4 divided by 8. With regular numbers, you want to divide, okay? So, -4 divided by 8. That's going to give me -0.5, but again, I want fractions, so I'm going to hit the little fraction button, and I get -1/2. So -1/2. So I'm going to go ahead and write that here, -1/2. And I'm going to go ahead and write out my fraction bar and make it bigger because, you know, there's other variables in here. I want to make sure I have room for everything. Okay, and then I see that I have like bases with the x's. I have x's in the numerator and x's in the denominator. So then you think about, where are there more x's? There's more x's in the numerator. How many more x's? Well, how many x's are in the bottom? There's 1. How many x's are in the top? There's 3. So there's obviously more in the top. How many more? There's 2 more because 3 minus 1 is 2. Okay? Now, I still have like bases of y, so I want to make sure I combine those together because you can't have any like bases in the end because you want it simplified. So where are there more y's? There's more y's in the numerator. How many more? There's 6 more because 8 minus 2 is 6. So this is as simple as it can get. So I'm going to go ahead and make this look a little bit nicer, and I'm going to center my 2. So it'll be -1x squared y to the 6th divided by 2. Now here's something else. Do I have to write the 1 that's in the front? No. Because remember, if the number isn't written there, there is a 1 there. But I don't have to write the 1 there if I don't want to. Okay? Now you can if you'd like. It means the same thing. Okay? So again, you can write the 1 there. And that's fine. Okay, last one, number 6. Okay, now here you're looking to see, okay, I don't have parentheses, so there's nothing for me to distribute. But I'm going to go ahead and be like, okay, any like bases anywhere? Yes, I do, right? Now, regular numbers, you would divide like normal because they're regular numbers. 2 divided by 5. So let's go ahead and do 2 divided by 5 and put that in a calculator. 2 divided by 5. Put that in fraction form and get 2 divided by 5. So what does that mean? It's already as simplified as it can get. So I'm going to have 2 divided by 5. And again, I'm making that fraction bar big because I still have a bunch of other stuff I haven't done yet. Okay, now I'm going to look for like bases. Well, I have like bases with the x's. Right? I have an x in the top and I have x's in the bottom. So then you go, where are there more x's? There's more x's in the top, right? Because there's 10 in the top and there's only 3 in the bottom. So 10 in the numerator. How many more x's? 7 more, because 10 minus 3 is 7. Okay, why am I subtracting here? This is the one where you think about it like a big minus sign. So I'm thinking about where are there more x's so I can cancel them out, because I don't want to have 2 different x's on both sides. I only want them on one side. Now the next variable I see is this y. Now the y doesn't have any like bases. So what does that mean? It means it gets left alone in the top. Nothing happens to it, can't do anything to it, so you just leave it alone. The next base I see are the z's, and I do have 2 sets of z's here, so I want to simplify this if possible. Where are there more z's? There's more z's in the bottom, okay? There's 7 in the bottom, there's 5 in the top. And then how many more? There's 2 more. Oops, there's 2 more. So you're canceling this out because you had 5 in the top, 7 in the bottom, right? So for example, 4, 5. Right, there's 5 in the top, and then there's 7 in the bottom. Okay, this is going to take me a while. Okay, so you're going to cancel everything that they have in common. So 1, 2, 3, 4, 5. So how many are left? Only 2, and they're in the bottom. And that's where that z to the 2 comes from. So that's what we're doing. We're doing a shortcut instead of writing it all out and thinking of it. So can you do anything else to this? Are there any other like bases with it? Nope. Literally can't simplify anything because if I type in 2 divided by 5 in a calculator, I get exactly that. So this is my final solution or my final expression because I can't simplify it. So those are our 4 laws of exponents. Oops, what happened to my line there? There we go. These are my 4 laws of exponents. Again, what did we have to begin with? We had the product law. If I have 2 bases being multiplied and their bases are the same, I can add the exponents because they're next to each other. If there's parentheses involved, always think multiply. So the only time you would add is if there's no parentheses. Okay? If there's parentheses, you're going to multiply those exponents. So with the power law and the product of a power law, you're going to be multiplying because you see parentheses. And then with the quotient law, this is where you subtract. This is when there's a fraction, so you have to treat it a little bit differently. You would subtract to see where are there more of that variable. So if you have any questions, please let me know. It can